Welcome to Mizzou Cloud DevOps YouTube channel. As part of the online learning platform for application-inspired cloud and DevOps curriculum, today I will be talking about our fifth module, which is related to VMware Tanzu. So I'm Roshan Nilpane, and so let's jump quickly over to the Tanzu. So this Lab 5 is VMware Tanzu on AWS with drone video streaming and analytics application. So the purpose of this lab would be to learn about VMware Tanzu Community Edition TCE platform and to learn how to use this to manage a Kubernetes cluster that is hosted on AWS Cloud. The topics of this lab will be installation of TCE on AWS EC2 instance and configuration, use of Tanzu CLI to create and manage a Kubernetes cluster, and once the cluster is created, we will deploy some example applications and deploy a use case application at the end. So the VMware Tanzu Community Edition is a full-featured, easy-to-manage Kubernetes platform for learners and users, specifically those working in a small-scale or pre-production environment. It is a freely available tool which is community-supported and has open-source distribution of VMware Tanzu that can be installed and configured in minutes on your local workstation or on your cloud. The command line interface is used for deploying and managing TCE. We use it to create a Kubernetes cluster and add additional tooling to build and deploy applications efficiently. Some of the commands that we're going to use is management cluster get and create to expose to expose different deployments, and the students will be learning about some of these commands to get the idea of how TCE command line interface works. So basically there are two different types of clusters. One is unmanaged cluster and the other one is managed cluster. The unmanaged cluster offers a single node local workstation cluster suitable for a development or test environment and requires minimal local resources and is fast to deploy. Whereas a managed cluster requires multiple nodes with higher resources, which are recommended for production scenarios, consists of a management cluster and one or more workload clusters. The management cluster is used to manage these workload clusters. So the use case application, we have drone video streaming and analytics, which is a image processing pipeline for object detection and tracking in video streams. We're going to leverage deep learning algorithms using darknet, YOLO, Coco in this application, and we will perform server client architecture to deploy onto the Kubernetes cluster. This kind of gives output of the video processing pipeline. As you can see in the left-hand side, there is an image of moving vehicles, and it's just the data is to track the number of cars or buses or trucks, and basically in the right-hand side you can see the video information being processed and classified. So in this tutorial or this demonstration, we're going to look over these highlighted stuff. We are going to create and deploy a TCE platform on the AWS Cloud, get familiar with the basic concepts and functionalities of TCE, use an example application of Pet Clinic to learn how to deploy on a TCE cluster, and deploy the use case application of the video processing that I showed earlier to learn more advanced concepts. To access this lab instructions, you can simply go to MizzouCloudDevOps.net. Now let's move over to the demonstration. So now that you've completed the installation or creation of the lab instance and configuring everything that you would require, what we would need to do is start the Tanzu TCE. So follow the command, which basically is Tanzu management cluster, create UI, browser, none. So basically this is a command line interface where you don't necessarily have a associated browser that you can use to look into the application. So that's why we give this none value here. So when you click on that, it will say the server is kickstarting, like the UI is being started at this address, which is basically a local host address. So again, to reiterate, you would need something that would allow you to like look at the browser, right? So for that, we need to use a certain technique, which is called SSH forwarding. And what we would do to do that is simply create a new terminal. And then from there, again, navigate to the key folder where you have that key that you created, and then simply copy the file, the command from the lab tutorial, and replace your values. For example, the key would be VMware key pair in my case. Again, do use your key name here, and under this VMIP, what we need is simply this public IP address, right, or the DNS value, whichever you prefer. Once you do that, it will basically work such that you created a SSH port forwarding. So that would mean that from like your own local machine here, that you can access this Tanzu UI. So to do that, let's just go to our localhost. Okay, there you go. So the community edition is already installed. From here, following through the tutorial, we need to deploy the Amazon Web Services and say start fresh here. And now let's start putting in the information, right? So the region we selected was East 1. Again, it depends on what you have. You hit connect, and when it says connected, as you can see here, you can progress. So if it does not configure properly, it would probably throw some errors here. So when you hit next, you would be prompted to create a new VPC. Let's just do that. Keep everything by default. In the management cluster, we're going to use the development mode, okay? And the instance type here would be t2.large. Again, note that you're creating a couple of new instances in your AWS using this. So you definitely need to state what kind of instance that you use. The name of the cluster could be Tanzu cluster, for example. The key pair is going to be the same one that you used. For me, it's VMware key pair. Pair. And the Bastion host is basically used for some security reasons. You don't necessarily need to do this for this lab, so I will just uncheck this. And again, because it's just the development mode, it's not the production, so you don't necessarily have to worry a lot about the security just yet. In the availability zone, use pick one. I would say I'm going to go with 1A. And then the node, the worker node that you're going to create with this process, you want to specify the instance type for it. When you do that, again, type in T2 large. Okay, so once you've done that, you can hit next. And for the metadata, it's not necessary. We're just going to skip this. For the network settings, let it be the way it is. Do not enable the proxy setting, and then just hit next. And from the identity management, the IAM, we just don't want to enable this for now. So just check this, like turn this off and hit next. And the operating system image, we're going to use the Ubuntu machine. So click that, hit next. You can review what you did. And if you feel like you've done the way that you expected, you can hit deploy management cluster. So it will take you to this page here. It will take about 15 to 20 minutes to set this up. So once you have this ready, you can progress. So let's wait for this to complete. Hello. So today we will be looking at how to perform the VMware Tanzu for Kubernetes Cluster Management Lab. So you would need to go to your AWS console, and from there you have to navigate to the EC2. If you don't know how to do that, you can just search for EC2 here. and click on the first option. I'm already there. So now what we need to do first of all is create a key pair. So I've already created a key for this task, which this is the one that I'm going to use, but I'll walk you through how to create a key pair. You can simply give a name, and depending on the computer that you're using or application that you're using, you can choose either .pem or .ppk. So if you're using PuTTY on a Windows machine, opt to select the PPK version. For everywhere else, you should select .pem. And once you give the name and then select this format, you can just hit create a key pair, and it will download your key pair in your local machine. So I have already downloaded my key pair, and it is sitting in my downloads folder. So the next thing we would do is create a security group. The security group that I plan to use for this, again, has already been created, but I can go ahead and create a new one. So basically, we'll start off with saying some name here. Let's say it's SG_Tanzu. We need to give some descriptions to run the Tanzu lab. And we need to add some inbound rules, which can be which need to be all traffic for this job. And I'm going to select anywhere IPv4, and also add a SSH rule here. This should basically take care of this also, but just to make sure, and hit create security group. So the name is SG_Tanzu, and give some description. Again, the name can be different from what I've given here, so you don't have to resort to using my name. So hit on create security group, and with the rules that are assigned, it should create a security group. Now, what we will do is create an instance. So as you might have already seen in the lab module, you will need a specific type of instance. So by hitting on launch instance, I can simply go to this. I'll be taken to this page. I'll give this lab a name, or this instance a name, which can be, let's say, Tanzu lab server, right? And then for the operating system, you would choose Ubuntu and keep this information the default, whatever there is. But for the instance type, we will be selecting the T2 large. It has 2 processors and 8 GB of memory, so should be quite sufficient for our lab. And in the key pair, navigate to finding your key. So we're just going to use this Tanzu key pair for now. Sorry, VMware key pair for now. And then from this network settings, we're going to select the group that we just created, right? We said SG_Tanzu. Yes. So that will be the selected security group, and then on the storage we want to give 30 gigabytes. So input 30 here, and it should basically just update here. So make sure that in the summary you're looking at T2 large, the security group that you created, the software image that is based on the operating system of Ubuntu, and also ensure that you've selected 30 gigabytes of memory, storage. Now hit launch instance. This should take just a couple of seconds to be successful. Once you've done that, you can click on this blue link to go to that instance information. And once you do that, you can see a lot of details related to this this instance that you created when you click on that blue link. So here the state is already running, so we don't have to wait for it. But before you begin, just make sure that the state is running. So from here, the main record that we're interested in is this public IPv4 DNS, or alternatively, we can use this address also. So what we need to do next is perform a SSH connection to this computer, and then we will progress with the rest of the lab. So I'm going to open a new terminal here, and like I said, I had downloaded that under my downloads folder under the name of VMware key pair, right? So this file is already here. I can ensure, but this basically ensures it. Now we're going to SSH into this instance that we just created by just locating that key, which is VMware key pair, and then using the username that is going to be Ubuntu, and then at the host, the host name that we failed to copy here. So simply copy the host name and then paste it here and press enter. First, if we're doing this for the first time, it will ask something like, do you want to connect? And you should just say yes. Once you do that, you will see that you're inside the EC2 instance. Now, what we need to do is, from the chapter 2, we need to continue to install the TCE application, right? So let's just clean this out first, clear, and then now let's try to download some of the dependencies that we will need for this lab. And for that, I will simply go on and say update. Just take a few seconds. Then I'm going to install a few dependencies here. Okay, so again, you should be able to find all these commands from the lab tutorial. So just hit on the enter on this line. It will download some of the important libraries and modules. And once you've done that, let's you should basically try to update the apt again. So with that, we will just say sudo apt -y update. Okay, so it is all the packages are basically upgraded. Now we need to download and install Docker, right? So for that, we will use docker.io and containerd. Right. So once you've done that, you basically download the Docker domain and everything that we use in this lab. Okay, looks like it's done. Now we want the Docker to understand or recognize this user Ubuntu. So the next line would be sudo user mod -ag docker Ubuntu. So it's just going to add Ubuntu to its known users, right? So let's verify the Docker has been created or installed. To do that, let's just look at the version. So yeah, the version of Docker is 20.10.12. This simply means that Docker is already installed. Now we need to install kubectl as part of this lab, and we will do that by simply saying sudo snap install kubectl classic. Right, it says it's installed, so why don't we verify that? We're going to type in kubectl version and then client. Okay, so if you see this information, that means the kubectl is there. Now we need to use the command line interface of Tanzu, for which, again, refer to the lab module. You'll find a link that you will need to basically fetch. So this command will go to this link and then fetch the repository from that link and save it to the computer, right? So once we do that, it will take a few seconds. And yeah, so let's see. If you do ls, see there is this file here. Now we have to unzip this file, and the command to unzip is this, which is simply going to be ran to create a folder which will have the installation code that we'll use. So again, let's look at that. So when you ls, you'll see a folder being created, something that starts with TCE. So why don't we go to that folder, and then let's install the script to download or install the Tanzu CLI, right? So the community edition is being installed. Again, it will take a few seconds. Perfect. the next step would be to install AWS CLI. So this is going to be Amazon's command line interface. So to do that, the command is CLI, enter. This might throw some like deprecated packages type of error or like warning. We just have to ignore that. Let's give it a few more seconds. Perfect. So just press escape here. Don't necessarily need to worry about that. And yeah, simply you're able to download it. Now what we need to do is configure the AWS, and for that we need some information, such as the access key, right? So from the top right corner of your console, click on your name, your account name, and then from there select security credentials. And if this is the first time that you're doing this, then it would probably say create access key, right? For me, I've already created this, so I don't necessarily have to do that. So once you do create a new access key, it will give you a CSV file, which will have the information such as the access ID and then secret key, right? So that's something that we will be using in the next step. So once we have this, again, download this to your computer, the CSV file, so that you can use it later. So from here, I'm going to say AWS configure. So here we go. So the access key is going to be something that you've already downloaded. So the file will have it. I'm just going to copy this. Okay. And then for the secret key, I don't want to share that. So I will simply take this off my screen for a few seconds and then update it and come back. Okay, and the next question it's going to ask is the default region name. It's simply US East 1 if you're using North Virginia. So just go on and enter that. And again, this is some information that you can find from here, the drop down here. So if you're using and like Northern Virginia, then you use US East 1, otherwise like whatever is reflective of whatever region you're on, right? So do that, and then when you press enter after you enter that information, you will be asked what kind of output format that you want to use, and we're going to use JSON. Okay, so once I've done that, so now that I've configured it, I would want to move forward with this. So simply this step would mean that you've completely you completed your initial steps onto setting up your AWS instance, and then your credentials and everything are all in place, so you're ready to start installing the Tanzu application. So it must have taken about 15 to 20 minutes to finish up everything. And now that the cluster has been completely installed and ready to use, you can go back to check that there are a couple of nodes that it has created in your AWS account. And the next thing we would do is verify the cluster and make some changes to the settings. For that, let's look into the different entities in this cluster. So for that, I'm going to use a management cluster get. So yeah, if you see something like this, it should definitely mean that your clusters are ready to use. So next, what we would do here is go on to capture the kubeconfig of the cluster. So say Tanzu management cluster kubeconfig get. You need to use the your management cluster name. For me, it's Tanzu cluster. So I'm going to say Tanzu cluster and then admin. So the credentials is saved. Now I can access the cluster by running this command here. I'll just copy that and then paste it here. Now it should change the context. So the context has been switched to the value that I've just inserted. Now let's try to validate the management clusters API server, which can be done by checking all the nodes. So the current status is ready for both these values. So that means we can continue to work on it. Now deploying a workload cluster. So let's try to create a workload here. And for that, I will go to this command to see that there is a YAML file. I'll quickly copy the value of this YAML file, and I'm going to perform the second command here from 3.4.1, and from here I would go back to this name of the file and replace it with the value that I copied over from here. So I'll just say, oops, that was a mistake. So let me retry doing it. So there is this command. Now I need to copy this. And then from here, I'm just going to go back to here and then paste that. So this value is what you're going to paste in this command. So it basically will copy the configuration file into a new YAML file in a different place, or like in the same place but a different file, which is worker.yaml. Now that you've done that, you want to change a little bit of values here, which would be, again, the next command, as you can see here. First off, I want to change this to say cluster name should be Tanzu cluster from earlier. And then everything else kind of should be the way it is. So just press enter. All this is doing is changing the cluster name from Tanzu cluster, which let's look at it first, right? So let's try to see if there is some value called Tanzu cluster in this config file, right? So if I copy this command or this path here, first of all, and cd into that, I'll see there is this new file called worker.yaml. So I'm going to look into what this value has. So worker.yaml, when I go in, and then when I check, the cluster name is Tanzu cluster, right? So we want to replace this to say worker cluster because we want to create a different cluster called worker cluster. So let's go back to our home page. And then from here, what we do is run the same command again. Here. So instead of the name is goes to my cluster, I'm going to use Tanzu because the command, the code in the tutorial had used my cluster as the name of the cluster. But once you do this, it basically changes the cluster name from Tanzu cluster to worker cluster. So let's press enter here. Now, if you want to verify again, you can go back to this value and then see if that the change has like been performed, right? So if I go back here and then check in the cluster name, it's now changed to worker cluster. So now what we're going to do is create this worker cluster, and for that what we need to do is simply copy the command from 3.4.2 Tanzu cluster create worker cluster and use the configuration file called the worker YAML that we just created earlier. So once I do that, it will validate configuration, and this might take a little bit of time again because it's creating a new cluster. So I would wait for this cluster to be up and running. Well, now once you get your cluster created, you can go back to check on your AWS that there are a few additional instances that have stood up, the worker cluster that you can see here. What we would do next is simply go to list this cluster, right? So once we do that, we can see that there is this worker cluster running. Now let's try to capture the kube config for this cluster. Okay, so and here under the workload cluster name, I would say, give me 1 second. I need to make sure that this is correct. Okay, so here it is. I'm going to remove this and then name it as the worker cluster. Okay, so once I do this, it will let us access by running this command here, similar to what we did earlier. So I'm going to copy this. Okay, so we can just simply run this command now. It will switch the context to worker cluster admin add worker cluster. Okay, so once you have reached here, you can now get all the pods related. So the pods are going to be fetched by using the get command, and we're also going to get the namespaces for all these pods. Okay, so if you see this, and like they're all in their running state, so these are basically all the pods that we have so far. So this concludes the chapter 3, where we basically perform the cluster creation. Now moving on to the 4th chapter, where we will show a simple deployment in this cluster. And so to begin doing that, let's look at the cluster information, which is basically cluster info command. Okay, so it says that it is the control plane is running and all that information is there. So now if we take a look at the pods, right? The pods. You can see there is no default resources, no resources in the default namespace just yet. So what we want to do is simply create a new application, and we're going to use like inline configuration for this. I would simply copy the command under the 4.2 section and paste it here. So okay, so this is basically the file or the YAML file, which can be used, or like YAML command, right? So which can be used to create a application called Pet Clinic, and we're going to deploy this into our cluster. So once I press enter, the deployment has been created is what shows. And now so what you can do is simply check the deployment of deployment and the pods here, which would be by using the command kube control get deployment. So you can see the Pet Clinic TCE lab is already deployed, and if we now move on to say get pods, there should be at least one pod, right? So we just created this new one. So yeah, the Pet Clinic TCE lab pod is up and it's also running. just quite frankly just created that, and now we're going to publish this. So by default, these application pods that get created do not necessarily allow external or internal traffic from other application pods. So in order to receive traffic, we need to publish the app to have a service, right? So since we're running the cluster on AWS platform, we have the option to use a load balancer provided by AWS. So let's create a load balancer service for this application. This will allow external traffic to reach the application inside our cluster. To publish the pet clinic using a service named pet clinic TCE, what you would do is simply use this command. So we're going to expose this deployment onto a port 80, and like the way to do this is by using a load balancer. So this basically means that the service has been exposed, which is simply, simply being published. So this would mean that we have created a new service, right? So to get that service, we will type service information. We'll type SVC, get SVC. So this is the load balancer that we just created like 23 seconds ago. Okay, so now what we can do is locate this load balancer, right? So one way to do that is simply copying this value here, and then by pasting it in the browser. But again, this is creating a load balancer in your system. If I look here, so this A846 is basically this load balance that you see here, which has been created. Sometimes this takes some time to load. So even if we run this, it may or may not have already been properly configured, so it may not work all right away. And so it's okay if it takes some time, basically. So, but actually it was already there, so which is good, right? So we've deployed an application which is basically the pet clinic application. There is a lot of interactions that you can do with this, like finding some owners and finding information on veterinarians and stuff like that. Yeah, feel free to play around with this application to get some information out of this. This kind of is the end of the example application scenario. And once we've done this, I would just simply get rid of this by deleting the service and the deployment that we created here, right? So to delete the service, what I'll do is simply use this command here, which will delete the service pet clinic TCE lab. Okay, the service deleted is what it is saying. It should have initiated the deletion of this service, and yeah, there you go. It's deleted. Now delete the deployment also, right? We don't need this deployment because we've already verified that this is working. So okay, I do that. All right. So now we're going to move on to the last walkthrough, which is basically using the deep learning method application that we have, which is basically an image analytics application that will perform object detection classification from a traffic video, right? So for this, what we would need is a repository to be downloaded into our machine. So why don't we go to the home folder, right? So cd tilde will take me there, and right now there is this the files that we all created earlier, but now let's try to clone the Tanzu demo repository that we have hosted, and it's also there in your lab tutorial documentation, so you can look it up there. Okay, so yeah, so it kind of doesn't take too long, so I can now cd into this to see the files inside of it. So for us to check the deployment configuration, we would need to go to this folder, image processing web services. For that, let's do cd image processing web services. And again, there are some files here. The server deployment is what we're going to take a look at the YAML file here will tell us the server deployment details, right? So let's just type in server deployment.yaml, and once we've done that, so it kind of gives us the information such as like this, right? Remember, there are some values here, such as your load balancer, which basically needs to be updated by certain information that we have. For that, what we're going to do is simply apply the kubectl to deploy the server that we created, right? So let's just do that now. So let's go to so we're already in the image processing web services. So make sure that you do this in this folder, this image processing web services folder, because the deployment file that we need to run is actually residing here, right? So here, so the server deployment is basically what we're trying to do. So now let's try to apply this, right? kubectl apply -f server deployment.yaml. So what this would do is simply apply the deployment for us. So here, I think we need to do some changes before we do this, and for that we probably need to at least provide the load balancer value here. Let's see what we can use, right? So we basically need the load balancer endpoint for us to insert into this value here, but even if we don't have that, we can actually initiate the deployment of server first, and then we can come back to pointing the load balancer inside of that file. And for that, we'll basically just run this command here. Okay, so it's basically has created a deployment and a service, right? So now let's try to get the pods to see if they've been created. Okay, so there is one which is in container creating status, which is not ready just yet. So we'll wait for this to be ready. Like it won't take a long time. So let's try it again. It's just been 30 seconds, so let's give it a little bit of more time. I'm just going to clean the screen, and then we're going to try to run the same command again. Okay, it's still in the container creating state, so I'll assume we would just wait for a little bit. Still working on it. It's been about a minute and a few seconds. Yeah, the deal with this is we're going to use some Docker image to basically create this container, right? So it's basically a Docker container that we're trying to pull from online, and this is normal. It should take some time, and once it is ready, we should be able to move forward with this. I'm just going to keep checking. Okay, after 2 minutes have passed, this cluster, oh sorry, the container is ready, right? So now we're going to move on to check the service. kubectl get svc. Okay, so look at this. So the service has been instantiated, which is using this endpoint here. So if I go back to refreshing here, the AF7B, as you can see here, this is the load balancer it created into my AWS account. Now I'm going to use this value, copy this, then what I'm going to do is update it in the YAML file, right? So to do that, what I will do is simply go back to the file, which is the server deployment. I can do that by using a VIM, which is a text editor, which will allow me to change values, right? So I would like enter here, and then where it says your load balancer name, I would update this value to whatever we had earlier. So we can also use SED to perform this, but you can simply use the value as what we have here. Just copy over, and then you can. So I think we should also place 5,000 as the port here, even though we're mentioning that the container port is going to be 5,000. Following the documentation that we're putting 5,000 here also. Now let's update this. I use the WQ to write and then quit. And now that we've done this, we can run this server deployment, which should definitely point to our new load balancer that we created. Okay, so it configured a few things. So the service has not been changed just yet. Now let's check the status, right? Hit pause. Okay, so status is it's running and ready for use. So now let's try to observe some server logs in this deployment. So I would say kubectl logs -f deployment / image processing server. So okay, so it's simply giving us some information such as running on Flask and stuff like what port is it running. So all that information is here. So let's leave this the way it is. Right now, let's open up another terminal so that we can do something similar for the client deployment also. For that, I would go back to my instances, Tanzu EC2, and from there I'll copy my public address for now, and then using a new PowerShell window, I'm going to SSH into that instance. I'm going to use my key that I created last time, and then I'm going to use Ubuntu @ the public IP address. It should take me back in that system. Now let's start working on the client deployment, right? So for that, let's go to this Tanzu demo folder. Inside of this, there is this image processing folder that you've already seen before. And when we list it, we can see that there is also this client deployment.yaml. So that's what we're going to work with. So let's see what it has. Client deployment YAML. Okay, so here also there's a value saying your load balancer name, which we need to update here. So the code above, like in the server environment, so we have to use the load balancer endpoint, right? So repeat like what we did for the server deployment earlier to change this value of load balancer to the load balancer address followed by the 5,000, right? So I mean, if you want to ensure what the name or the value of this is, you can do a couple things. You can probably check to grab the service value, right, which will basically show the same value as our load balancer, and then you can copy it over and go back to the client deployment YAML file and then insert this value into this section here, where we will remove your load balancer name value and then paste whatever we had. And then now I'll save this. Okay, so now we've pointed the load balancer information to the client deployment also. Now, after this, what we're going to do is we're going to apply this deployment, right? So when we do that, you'll see in a second. Dot, okay, I had a typo here, kubectl. Okay. All right, the new deployment has been created, which is called image processing client. Okay, now let's get the pods. See, now it's going to create the container for the client. We already have our service running for the server, and we might need to wait for a little bit again, similar to earlier, to have this container readied. Quite possibly when this starts to run, we could get some output in the server side of this. This is basically the server. This is the client, right? Let me just make it look here. All right. So if I just do this again, it's running. So maybe this is not updated just yet, but let's give it a few seconds. Okay. Yeah, let's wait on this. So here's the deal. I think I missed a little bit of information here. So when I was updating the Vim client, I forgot to insert the port, right? So I think that's why it's not updating just yet. So if I go here and then apply this, hopefully this does not break anything. And then I run the kubectl once again. Okay. So it's configured. Now you can see there is some movements here, right? So this means that the processing of the values or the data that we were trying to use, the image processing for the traffic, it has started here in the left hand side, as you can see it. Let's let it run for a little bit. This basically will, like, is something that is happening from the client. So the client is sending some video frames to the server, and the server is basically performing the object recognition and counting. So let's run it for a little bit, and once it shows some data related to like cars and trucks and buses, like here, right? So we can now see that the data has already been populated, and we can run this for a little bit more. And once this is ready, we can just stop this. Now, when we're at it, let's see if there is some data that has been populated in the client, or you could use either the client or the server container. So again, let's look at the pods. Get pods. So you can see that the pod name is something like this. Let's copy this guy, and we're going to try to log into the system, right? So for that, what we will do is use this command called kubectl execute it, the name of the pod, and then we're going to use the bash. Okay, so now, as you can see, we're inside this image processing client, and so once we do this, we should be able to see a few things here. Now, inside of this, let's go to the output folder. Okay, so we're inside this output, the server folder, and now what we can do is check if this has anything. So there is this file called output, but it's only like right now it's only like the output full file. So what we need to do is Actually, the the details would be, if we're using the client, we should be looking at the client folder instead. So in the output, there is one client and one is server, right? So let's go to the client folder and then list the values here. So there is this result.txt, right? So basically, we're going to access this file here. So if I terminate this from here, okay, so and let's look at this file here. We have the file called result.txt. So the result.txt will have the result of our the processing that we did, which is basically going to show us. And the thing is, we could check the value of this result by going into the file to print the first 20 lines. So these are all the frames and everything created inside of this. Okay, I don't know. Okay, so these are the first 10 lines of the result. You can see like all these processing are happening within. And so basically this means that you're able to see the results of your the classification, right? So it has some values which can be utilized to identify, like understand, like, you know, what information, like at what frame per second rate and what frame number, and like, you know, are they properly being sent, which is basically the response of 200. So there's a lot of things that you can gain insight on from this. So that basically concludes our demonstration. So thank you so much for listening.